These are the components for the gas turbine engine fuel system. The one on the top left is called the fuel tank. The fuel tank is the operating fuel storage component of a fuel system. As for the top right, it's called the fuel boost pump. The boost pump is usually located at the lowest point of the fuel tank. It must be available for engine starting, takeoff, landing, and for use at high altitude. It must have sufficient capacity to substitute for the engine-driven fuel pump in case the engine-driven fuel pump fails. The one on the bottom left is called the shut-off valve. The shut-off valve is a flow control valve that can be used to stop a flow of fluid. A low-pressure cock in the aircraft fuel system is a type of shut-off valve. As for the one on the bottom right, it's called the low-pressure fuel filter. It is installed in the system to remove any large pieces of foreign material from the fuel which might cause damage to the engine-driven pump. The one at the top left is called the main fuel pump. It is a pump that pumps fuel from the fuel tank to the engine. The one on the top right is called the fuel filter. It is similar to the low-pressure filter. It removes any large foreign material from the fuel which might cause damage to the engine-driven pump. The one at the bottom is called the main engine control. It controls fuel flow to the engine. The one at the top left is called the oil cooler. It transfers heat from the oil to the fuel and thus prevent blockage of the filter element by ice particles. The one on the top right is called the flow divider. It is a component in the fuel control system of a gas turbine engine that routes all the fuel to the primary nozzles when starting the engine and when RPM are low. When the engine speed builds up, the flow divider opens a passage to send a majority of fuel to the secondary fuel nozzles. The one at the bottom is called the fuel nozzle. It is a nozzle in a gas turbine engine combustor through which the fuel is discharged. The spray pattern from the fuel nozzle is such that the flame is always centered in the burner so that it will not overheat. Fuel enters the system from the fuel supply and then passes through a low pressure pump and then through the high pressure pump where it is pressurized up to several hundred psi. From the high pressure pump, the fuel enters a fuel/oil heat exchanger which is used to cool the oil. The fuel filter is next in the flow path to the engine. The filter has a bypass valve that will bypass fuel if the filter becomes clogged. The fuel then passes into the main engine fuel control which meters the amount of fuel the engine requires for a given engine condition or RPM. Fuel on its way to the engine enters the pressurizing valve which either directs the fuel to the engine or dumps them. The fuel control unit controls the amount of fuel to be metered into the combustion chamber to provide the optimum fuel/air ratio for combustion. The fuel continues through the fuel flow transmitter and onto the fuel manifold, which distributes the fuel to each fuel nozzle. There are many misconceptions of the usage of steel in the fuel system. Some companies prefer the usage of plastic in the fuel system as they feel that steel is too costly, it has a lesser design flexibility, it has higher mass, it is non-environmental friendly, and it rusts and corrodes.
Also, the steel has a better life cycle compared to plastic. The life cycle of a plastic fuel tank starts off with feedstocks, where the required materials are acquired. This is followed by compounding, where the materials are mixed to form plastic. Fuel tank manufacturing comes next. Once the tanks are made, it is assembled into the fuel system. At the end of its service life, the tanks are disposed of. The life cycle of a steel fuel tank is much different. It starts off by refining the iron ores. Then the iron ores are processed into steel. Tank manufacturing comes next, and after the tanks are manufactured, they are assembled into the fuel system. At the end of its service life, these tanks are dismantled, but unlike the plastic fuel tanks, these steel fuel tanks are scrapped, and the whole process starts over again. Because the steel tanks are 100% recycled, there is no impact on the land resources. The amount of tanks placed end to end would stretch 229,000 kilometers, almost 6 times the circumference of the Earth.
Developing more sustainable jet fuel is vitally important for the global aviation industry and for the Qantas Group. The environmental impacts and energy security issues associated with traditional fossil-based jet fuel mean it is imperative that we push hard now for the commercialization of alternative fuel sources. The environmental challenges of aviation can only be met if all stakeholders contribute to the effort. Sustainable Aviation Fuel, SAF, is a name given to advanced jet turbine biofuel made from next-generation biomass sources such as algae, municipal waste streams, waste tree oil, and specially selected types of biomass energy crops which do not compete with food crops. With the introduction of SAF, thousands of new clean energy jobs are created. The SAF strongly contributes to economic and regional development. Overall, reducing environmental footprint. Climate change and energy security problems will be solved.
One topic we can look into the gas turbine fuel system is actually not the system itself, but more the item that makes the system works, the fuel. The fuel plays a very important role in maintaining and the overall efficiency of the system, since some fuels have a higher fuel efficiency than others, being able to convert more chemical potential energy to work, and have different viscosity levels.
We can also look into the materials used in the fuel system. For some components, such as the heat exchanger, a material with a higher melting point should be used so that it can withstand more heat. Heat which is transferred to the fuel so that it will require less energy for combustion later on, thus improving the overall efficiency of the fuel system. Materials with better wear and tear resistance are also required for a longer lasting fuel system so that it does not have to be changed as often as it is now.